Hello everybody, today I will expose this presentation under a title of Deep Learning Approach Based on FCRBM for Optimization of Electric Energy Production. This work is done by Chaimaa FOUHAD, Mohamed KHAILI and Mohamed QBADOU. Hope you enjoy. The production of electrical energy has been a subject of concern to scientific researchers since the invention of electricity. Of course, production without losses does not exist. These energy losses have given way to the question of how to optimize the production of electricity. This presentation consists of 4 sections. We start with brief summary of state of the art, then we will discuss conditional restricted Boltzmann machine (CRBM) and factored conditional restricted Boltzmann machine (FCRBM). In the third part, we will introduce our model with its implementation architecture. Simulation results will be available once the datasets are received. Finally, we will reach a conclusion. In addition, demand decomposition makes it possible to analyze energy consumption patterns and to identify energy conservation objectives. Moreover, forecasting temporal energy consumption allows managers to plan energy consumption over time, move energy used in peak periods, and prepare more favorable energy purchase plans. Traditionally, demand of forecasting can be considered to fall into 3 categories. Short-term forecasts are generally applied at interval of 1 hour to 1 week. Medium-term forecasts are generally 1 week to 1 year, and long-term forecasts are for more than 1 year. A good prediction is also a result of effective predictive analysis. It is in this context that several knights of science have set themselves as a challenge to obtain an effective predictive model based on the contribution of new technologies. Amir Mousavi did a study based on machine learning and demonstrated how the technique used by machine learning can improve the accuracy in the prediction of the production of electrical energy. Amir Mousavi, Marija Zeki carried out a study on the contribution of machine learning in the production of energy in the public sector and also demonstrated the benefits that this new technology can bring in the electrical energy sector. Elena Mokanu set as a goal to improve the efficiency of the entire electrical system and demonstrated that by using neural network-based prediction methods, learning techniques are expected to improve the performance and accuracy of prediction by allowing higher levels of abstraction. To do this, 2 stochastic models were studied, the CRBM and the FCRBM. A comparison showed that for the problem of prediction energy production, the FCRBM surpassed the artificial neural network (ANN), support vector machine (SVM), recurrent neural networks (RNN), and the CRBM. Taylor and Hinchon introduced the factored condition restricted Boltzmann machine, where they added styles and the concepts of factored, multiplicative, three-ways interaction to predict multiple styles of human motions. This is the general architecture of FCRBM, where U is the conditional history layer input, H is the hidden layer, Y is the style layer, and V is the visible layer output, where denotes binary neurons, represents the real values and the others are Gaussian values. Energy function for this model is like that, where WV, WY, and WH represent the factored visible, factored hidden, and factored label wages, respectively. X, Y is the Hadamard product, also known as the element-wise product, between matrix X and Y, and F represents the index of all factor. The term alpha and beta are called dynamic bases and are defined as that, where AV, AU, AY, BW, BU, BY are the connections from corresponding layer to the factors. These, as well as the wedges connections, are free parameters that need to be trained are as detailed in following sections. Since there are no connections between the neurons in the same layer, inference can be done in parallel for each unit type, leading to that. Based on the various articles results, particularly those mentioned above, we will start for all predictive analysis to improve the production of energy in electrical system with the FCRBM model approach with some exception related to our vision. Simulation results will be available once the datasets are received. For project context, deep learning is a set of methods for machine learning, the aim of which is to model data at a high level using nonlinear transformation architecture. The aim is to take advantage in the field of energy production of methods related to deep learning to obtain an expected optimization of energy production. We will be particularly interested in the transport layer for said energy improvement. The modeling process aims to obtain an understandable result by the computer system. The final solution is a series of interactions. Several steps are necessary for this purpose. These successive steps allow to refinement of the level of details of the system to be carried out. Early steps provide vision to very large gains and advanced understanding of the problem. In the current environment, the choice is based on the FCRBM model. To conclude, energy forecasting is a difficult issue because it depends on the complexity of the energy building's behavior and the uncertainty of the influencing factors, leading to frequent fluctuation in demand. We adopted the factored condition restricted Boltzmann machine model because it was effective compared to the others in the same categories. It can withstand fluctuation due to building architecture and thermal properties of the physical materials used, occupants and their behavior, climatic conditions and sub-level system components such as lighting or HVAC, heating, ventilation, and air conditioning. The practical tests will validate the effectiveness of our approach in comparison with similar methods. Thank you for your attention.